Today we're going to look at section 2.5, which is about perpendicular lines. We're going to define what that means and then have a few theorems about perpendicular lines and what they can do. With this definition and these three theorems, we need to really focus on what are the key words here. What are they saying? Some of your problems are going to ask you to justify statements. And to choose the appropriate one of these four things, we really need to focus on exactly what are they all saying. Because they're all talking about perpendicular lines, but they all say something a little bit different about perpendiculars. So we have to focus on the important phrases in here. The definition of perpendicular lines says that we get right angles. So if our statement says something about having perpendicular lines and having right angles, that's going to come from our definition. That little symbol there that looks like an upside down T is our symbol that means perpendicular. So when you see that symbol in a problem where it says a line and then that symbol and another line, that means those two lines are perpendicular or that they intersect at right angles. Theorem 2.4 says if we have perpendicular, then we get congruent angles that happen to be adjacent as well, right next to each other. Okay? If they are perpendicular, then they are congruent. They form congruent angles. So if we see something about perpendicular and right angles, we're going to be talking about our definition. If we see something about perpendicular making congruent angles, that's going to be this theorem. So we're going to have to pay attention to the actual words of the statement. Theorem 2.5 says, if we have congruent angles, that means that we also have perpendicular lines. It's almost the same as Theorem 2.4, but what do we call Theorem 2.4 and 2.5? Converses. They say the same thing, but they say it backwards. And order does matter. So when we're justifying, we're going to want to pay attention to the order of those two things. If perpendicular, then congruent angles is Theorem 2.4. Whereas the other one, if congruent angles, then perpendicular, is Theorem 2.5. So they use the same key words, but we have to pay attention to that order. Yes?
So if we're stating these as reasons, how will we state them?
Good question. On your homework, if the questions ask you to just justify, you can go ahead and use the numbers. When it comes to the test, as with the last test, I'll give a word bank for this one, and these will be on there. What we will move towards after this chapter, when we justify, is instead of justifying by numbers, we're going to justify by just saying the words themselves. But I'm lazy, so I don't want to write out this whole thing. So like if I were justifying using Theorem 2.4, what I would say is, if perpendicular, then congruent adjacent angles.
And the other one you just do.
And the other one.
Adjacent angles, then.
Yep. So I'm saying what the theorem says, but don't feel like you have to write it all out. We use a lot of symbols in math because we're kind of lazy people when we do math. We want to do something efficiently. In your homework, when you're justifying, though, you can feel free to just justify them by number, since you don't have to memorize them and you'll be able to have your notes out while you're working on your homework. The last one here says, if the exterior sides of adjacent acute angles, so that's something new, we haven't talked about acute angles, perpendicular, complementary. We've got lots of keywords in this one. This one says something totally different than the other ones. A picture for what this says, exterior means outside. So if the outsides are perpendicular of two little angles, those angles are complementary. Yesterday we learned complementary means adds up to 90. So it's saying if there's two little angles fitting inside of a right angle, they add up to that right angle. Okay, so this one's got a lot of different words. This one's a little bit easier to pick out than the other ones, which seem a lot more similar. Questions on what any of those say? Okay, we're going to prove Theorem 2.4 here. We got some fill in the blanks. So what would our first reason be here? How do I know L is perpendicular to N?
Given.
They gave us that information. Usually the first reason, not always, but usually we start with a given. And for the second one, it says, knowing that we have these perpendicular lines, how do I know that that is giving me 4 90-degree angles? This one can actually be two different things. We could say it's our definition of perpendicular, because perpendicular means that we get right angles. Also, since this doesn't say that we have right angles, it says that we have 90-degree angles, we could say that it's the definition of right angles as well. So somehow knowing that we have perpendiculars tells us that we have these right angles or 90-degree angles. So then step 3 says, well, if they're all 90 degrees, they must be congruent. And so that's the definition of what, do you think? What tells us if they're all 90, we can call them congruent?
Theorem 2-5.
It's going to be a definition of a term. So what term tells us if they're all 90, we can call them congruent? The term is actually in there already. Congruent. That's what congruent means. Is if they're all the same size, then we can call them congruent.
What's that other sign? Like after the number 2, perpendicular, that's
Right angles. So because they're perpendicular right angles. Okay. So that's what congruent means, is since they're all 90, we can call them congruent. In this diagram, we are given that we have 2 sets of perpendicular lines. AB is perpendicular to CD, and EF is perpendicular to GH. That means I should have 8 right angles in this picture. I would suggest when you need to name off a lot of something in one picture that you do so in an organized fashion. Because if you just start to randomly grab, then once you get down to having like 6 or 7 of them, you can't figure out what 1 or 2 it is that you're missing. So I'm going to start with A, because alphabetically that seems a good place to start. It's also right at the top. And AOD is going to be my first right angle there. And then I can circle around. So what one would come next to that?
BOD.
Okay, so BOD is right next to that. And then working my way around, get COB and AOC. Remember, the order of the letters doesn't matter, so whether we call it AOD or DOA doesn't really matter. But I'm focusing on just one set of the perpendicular lines, completely ignoring those ones that are kind of offset. Get 4 right angles around there. Then I'll switch my focus. And now I want to focus on the lines that are offset. And I'm going to start near the top, EOH, and then work my way around. HOF, FOG, GOE. Okay. So focus on just one set of perpendiculars at a time and work your way around in a circle. Otherwise, when you get to the end, it's hard to figure out which one it is that you're missing. Or you could end up naming the same one twice, but you used the letters backwards and you didn't notice. Okay. Questions on how to find those angles? In this picture, everything's flat on the paper. In this picture, it is not. So here we have a 3-dimensional image. We are told in this diagram, OZ is perpendicular to PQ. Got a perpendicular there. We are told OZ is also perpendicular to XY. So that is a right angle. It doesn't really look like it, but it is. And we are told that PQ and XY are perpendicular. Again, they don't really look like it, but we're told that they are. So what we have happening here is a plane or a flat sheet of paper with 2 perpendicular lines drawn on it. Point Z is floating directly above the middle and connecting straight down. So there should be 8 right angles in this picture again. To start naming them, I'm going to start in the plane with the 2 lines that are there, starting kind of at the north of it. I get YOQ. Then working my way around, I get QOX, XOP, POY. I should have 4 more, and they're going to use that floating point. So starting then, again, kind of towards the north, I'm going to go ZOY. And then out to each corner, ZOQ, ZOX, ZOP. Questions on how to locate those right angles or what this would actually look like if it weren't flattened onto a paper? Our last part then is on justifying. So this is where I said it's important to pick out those key phrases and what that definition and those 3 different theorems are actually saying. Because they all say stuff about perpendiculars, but we need to be specific about which is saying what. So our first one here says, if right angle, then perpendicular. So of the definition, theorems 2.4, 2.5, or 2.6, what one talks about right angles and perpendiculars?
Theorem 2-6.
Perpendicular.
2.5.
2.4.
Okay, so we need one that specifically uses the word right angle
Perpendicular lines. That's
and perpendicular. The specific word right angle and perpendicular.
oh.
Perpendicular.
That's our definition of perpendicular lines. Theorem 2.4 and 2.5 talk about congruent angles, not necessarily right. They are, but it doesn't say that. It says congruent. Theorem 2.6 does talk about right angles, but it's talking about also acute angles, and this one doesn't say anything about acute angles. Okay, so this one's missing some information that would be necessary for Theorem 2.6. The next one says, if perpendicular, then I get right angles.
2.4.
So what one says something specifically about perpendicular and right angles?
Definition.
The definition again.
You know what? That was just beautiful.
It's not even cool.
The next one says, if perpendicular, then congruent. So what one says specifically in that order, perpendicular, congruent. 2.4 says it in that order.
Oh, yeah.
If perpendicular, then congruent. The next one says perpendicular and 90. Well, what is a 90 angle?
Right.
A right angle. So this one is saying perpendicular and right angle.
Definition.
Definition. The next one says congruent, then perpendicular. Specifically in that order, what says congruent perpendicular?
2.5.
2.5. The last one says 90, which is really meaning a right angle and perpendicular. That's our definition. We did not use theorem 2.6 at all here because 2.6 needs something else. 2.6 says if the outsides of 2 little angles are perpendicular. So I would need little angles for that one to work. And we didn't have that in this picture at all. Okay?
What are you talking?
Any questions on any of these?
Or 6.
Okay. Your homework tonight is from section 2.5, 2 to 25. There are a couple proofs. I think they're all still fill in the blank, so make sure you look for that so you don't have to try to totally do it on your own, unless there might be one that is, but I think they're all fill in the blank.